Hi, in this tutorial we're going to use Google Spreadsheets to learn how to solve straight line equations and graph them. And so let's get started. If you open up your spreadsheet, you can follow along and copy what I'm doing or try this after the video. So I have opened a blank spreadsheet, and you could do this in Excel as well, but we'll use Google Spreadsheets since we all have it. Let's suppose we have some data points, and let's say we have a set of x values and a set of y values. Let's say our x values are 2 and 5, and our y values are 8 and 14. This is basically like having the ordered pair 2, 8 and 5, 14. And so what we want to do is graph these points. And as you know, you can find an equation that goes through both of these points, and that's what we're going to use this program to do. So what you want to do is, let me get rid of these, highlight the data, and you can even include the headers x and y, and click on Insert Chart. We'll go to the tab that says Chart Types, and you'll notice there's a checkbox here, Use Row 1 as Headers. We do want to have that checked because Row 1 has the titles X and Y. So that's not part of the data, that's actually the title. So make sure that's checked, and we're going to use the scatter plot chart. Then we go to the Customization tab, and here you can change the title. We're not going to spend any time on the formatting of all this. We're going to focus more on the math skills you can get out of using this program. So we're going to scroll all the way down to the very bottom, and it says Trendline. You can add a trend line. So go ahead and click on Linear. And when you add the trend line, you can actually see the line that connects the 2 points, and there's an equation that would fit these 2 points. And you can see right here, when I highlight my cursor over it, it says y equals 2 times x plus 4. Well, we want to have that equation show up permanently. So under the Label tab, you click on Use Equation, and now the label has the equation on it. So go ahead and press Insert, and here's our chart. And this is the line that goes through those points. Now you'll notice that the axes are auto-scaled, and so this scale goes from 8 to 16. I'm going to change that, so you just click on the 8, and it brings up a minimum and maximum. I want to change the minimum to 0, and I'll leave the maximum alone. And so now we've scaled the chart slightly different. So now you can see where your y-intercept is. We can't really see the x-intercept unless we increase this. So maybe I'll do that. Let's make this, say, a minimum of -10. And now you can see it crosses over right about here. It doesn't tell you what the exact point is, but we can figure that out later. So now we can see the whole x and y axis data. Okay, let's use that equation now. That equation says that this data is modeled by the equation y equals 2x plus 4. So how do we use this equation? Well, what we're going to do, let me drag this down to get it out of the way. Move it over here. And I'm actually going to move this equation right where it says y, because that is what y is. Y is 2x plus 4. So I'm going to move this and put it right there. Okay. And now, instead of having this data appear like this, I'm going to type in an equation down below. And we're going to type in the equation. Instead of saying y, we're just going to type in equals 2 times x plus 4. But x is the data that we want to use. So we're going to get rid of the x, and we're going to click on the box right next door, this empty box. Cell A4 will be our x value. So we're going to take this x value, multiply it by 2, and add 4. Press enter. And so notice there's a value there. It says 4. That's because there's nothing in the cell, so it assumes it's a 0. Okay, so if I were to change this to a 1, watch what happens to the number. It changed. The y value is 6 when the x value is 1. If I change this to a 2, you should be able to guess what the answer is going to be. Now the value is 8, which is the exact same thing we had up here. So what's neat about this equation is it will allow you to figure out what values are in between. So we can't really see any values except for these exact 2 points. So what about the number, say, 3? If we put a 3 in here, you can see that it'll show up, and the y value, the corresponding y value, is 10 when x is 3. So what I'm going to do is take this equation and drag it up. And so now instead of in this cell having just a plain number 8, you can see that cell actually has the equation in it, which is the same as having the number 8 in it, except it's now updatable if we change the x value. And every time you change these values, it changes the chart. One of the cool functions in here is the slope and intercept functions. So we can see that the slope is 2 and the intercept is 4. Well, if I type in anywhere in here equals slope, open parentheses, I can select this data right here, and this says to select the y data first. So I select the y data and then press comma, and now I select the x data. So I'm going to select these 2 cells as my x data and then press enter. And what it did is it actually found the slope of that set of data. And that's exactly that number right there. So the slope is 2. The y-intercept is 4. So I'm going to make sure that works. I type in intercept, and you can see what it's going to give us, the y-intercept. Open parenthesis, I'm going to select my y data first, comma, x data, comma. So you want to be careful because normally you are used to placing x first and then y, but it wants it in this order instead. So there is my y value, my y-intercept value. So if we wanted to be, a little bit smarter about the way we do this, is we can say our formula is actually equal to m times x plus b, where 2 is our m, that's our slope, and x can be anything we want it to be, and we can use any value in any cell we want, and then add b to it. Now, when you do that, it gives you an error because we haven't defined what x is. So if I wanted to, I can get rid of the x and click on one of these x values and press enter. And notice this is equal to that number right there, which is what we expect it to be. So that's the slope and intercept function. All right, I'm going to add a new sheet. It's down here, sheet 1 still retains the old data. We might want to go back to that. Sheet 2, we're going to try something else now. We're going to graph the equation y equals 3x minus 4. Okay, so just like before, we're going to have our x values and our y values. And let's make up a few x values. Let's say 1 and 2. And our y value is going to equal 3 times the x value minus 4. So this really can go right here. This is what y is. Y is equal to 3x minus 4. If you want to get rid of a row, you right-click on the row number that you want to get rid of and press delete row. Okay, so we're going to type in the actual formula in here, and anytime you want a formula that's updated, it starts with an equal sign, and we'll copy this formula up here. 3 times x, and x, this is our x value, minus 4. Enter. I take that and I drag it down, and there is our 2 ordered pairs. Now let's graph this just to make sure it looks the way we expect it to. So I'm going to highlight all the data, including the titles. Click Insert Chart. Go to Chart Types. Make sure this is still selected since we have highlighted our actual titles. If you don't highlight the titles, then you would uncheck this. But since we've highlighted those titles, you keep it checked. Click on Scatter. Go to the Customization tab. And we're going to add that trend line. Let's add a trend line, a linear trend line. Okay. And again, we want to give it a label. Now notice over here the label says y equals 3x minus 4. That's just from the title. So it hasn't, that's just text. It's not an actual equation. We need to give it an equation. And look, it matches perfectly. Y is equal to 3 times x minus 4. So that's one way to graph an equation. So if you have an equation that you want to graph, you can set it up like this, give it some fake inputs, and graph the ordered pairs accordingly. So if I take these and I drag this formula down, you can see now for every point we have an output. Now suppose, I'm going to add a new sheet, let's suppose you have the equation 4x plus 2y equals 9. You know that if you plug an x value of, say, 1 into the x value, then the y value has to be a specific number. For every x value, there's a y value that goes with it. So the question is going to be, is the ordered pair -1, 6.5 a solution to this equation? So if I were to plug in these numbers, -1 into the x value and 6.5 into the y value, will that equal 9? And so we're going to use Google spreadsheets to do this. So we'll type in the numbers just like it looks. This is going to equal 4 times x, and my x value is -1, plus 2 times my y value, which is 6.5. Press enter, and there it is. It must be true. Another question that might come up is whether or not a set of data is linear. So, like I mentioned before, you might have a set of data that may look linear, but you're unsure of it. So let's make up some data, say from the year 2017 2018, if you say you made a salary of $60,000 in the year 2017, and we can click on that and turn it into an actual dollar symbol, $60,000 in the year 2017. Let's say the following year you made $65,000. If you were to continue making $5,000 more every year thereafter, that would be linear. For every 1 year, you gain $5,000. But as you know, that will not, unfortunately, be the case for the rest of your life. Let's say the next year, 2019, you made $69,000. Let me not put that comma. $69,000. This is not linear because it has not increased the same amount. And maybe you'll eventually trail off in the year, say 2030. And by that point, let's just assume you're at 83,000. So you kind of hit your ceiling after 13 years. So let's look at this data now. Let's graph the points. So I'm going to highlight all these points. Insert chart. And you can see right away that it's not linear. This graph that automatically pops up is not a straight line. If it was a straight line, you know it's linear. So we're going to go to chart types. And scroll down and choose the scatter plot. Go to Customize, Customization tab. Scroll down, and we're going to add that trend line. Okay? When we add the linear trend line, since it's linear, the line that we added is linear, but our data is not, you can see that that line has to just basically find the best fit in between the data points. So it doesn't fit all the data points perfectly, but if it was linear, then it would fit along that line. So it's clearly not a linear because all these data points would have to have lined up along that line. If we click this box that says show R² value, we click on that, it shows an R² value equal to 0.94. That basically shows how close that linear trend line equation is to the true value. This is the equation, 1581 times x minus 3.128 times 10 to the 6th power. And so if your data fit that equation perfectly, this R² value would equal 1. So 0.91 is being perfect. So 0.94 is pretty close to being linear, but not quite. If you wanted to, you could add a polynomial line that will fit this data a little bit better. Hopefully this is not your actual salary, because by the time you retire, things are looking down. So there's different sorts of fits to this type of data. All right. So hopefully this will help you out in any of your homework problems. I would try this out on some actual problems that you have to do. Use Excel or Google Spreadsheets to do the work for you and use it as a tool. Thank you very much.